Good afternoon again. So we have been on dimensionality reduction. And I remember in our last class, we only theoretically explained what it means to reduce your data sets or frame dimension. And we are able to pick out some of the advantages of the data scientists considering this. We also looked at different aspects of machine learning where we can help situation with dimensionality reduction. We also compared it with data selection, right? And we did mention that it's quite different from data selection because in terms of data selection, you are absolutely removing an entire feature and its value. But in the case of dimensionality reduction, you are compressing, you are not actually, though in the process, you might be losing some information, but not totally losing everything within your data sets. So I also highlighted the objective of this section, and I said our goal for this section is to learn how popular dimensionality reduction technique fundamentally works. They also apply and interpret the results of PCA TSE model in Python. And then we looked at this. We use this as a graphical illustration of the entire concepts we are talking about. So where I have this data set with 3 different features, and then at the end of the day, we have grouped them or reduced the dimension from 3 dimensions to 2 dimensions. And remember, we talked about the logic behind it. That was the reason why I did not consider any practical in that class, because I wanted us to spend time to understand the theoretical aspect. What with the functions and the libraries we are going to use in this section will be doing for us. So in that last class, I have been able to walk all through the entire logic where you start by identifying what. Let me know if you are following. What is the first thing you think logically the function that will be involved we do? What are the steps? Remember, we highlighted some steps. Let me know if you are still there. Can anybody try? Create, identify what? Center what? Point. Followed by what? You rule what? Either a perpendicular line or what? A parallel line, or depending on where the center is, and the possibility of attracting so many data points around it that will determine whether you can actually reduce the column. Because if there is no association with the line and the center, then it is impossible for you to reduce the dimension of that data. So here we try visualizing it. And then if you can see here, what we are trying to picture here is when the data feature are much, it will be difficult for you to determine or to work with a cluster that will help you to probably get the metric or the parameters you are looking for within your data. So we'll talk about why reduced dimension. We highlighted that in EDA is applied, supervised learning and unsupervised learning and all of that. Just to quickly get to where we stopped. So we also looked at this. just to be able to know out of the 6 different workflow or data science or supervised machine learning workflow, at which point this particular concept will be of useful. And that is what this diagram is showing at number 4 and number 5, where you will be exploring data and also modeling data. You will prioritize reduction of your features or the dimension of your data. So we'll also talk about principal component analysis. So this is actually giving us the breakdown logically how the function is going to achieve this entire process. So we look at some of the components, and then this still part of that, trying to route different lines and see how many data points can associate with it. Quickly, so that we can go into the plan for today. All these we have discussed them in the last class, and we talk about summing and squaring, right? The value, how it's going to, we're going to see all that. You see how easily Python is going to handle all these processes that we have explained so far. All right, so this is where we started by importing the main function, which is what? The PCA, from a library called sklearn through the decomposition. And then we store it as an object series as PCA, and then we equated the library component, the function, and then specify the numbers of components. So where you have number of components equals to 2. Can anybody still remember the interpretation of this? How will you interpret this section? What does that mean? The number of what? Columns, right? That is, if you are given a data set that have 20 columns and you define 2, it means that you are saying that collapse everything to what? To 2. Good. Now, now this is where you center, because remember we talked about using the centric method, right? Identifying what? The center before ruling the what? The line. So one way or the other, everything we are going to learn in this section, if we have a good picture of what we did last time, it will help us to understand better. So let me just quickly, I think I've explained all this one, or I have not? No, I have not. So we stop at here, right? But we have not, which one? This one? Okay. I've explained this, right? The entire process we want to go and practicalize what I'm trying to highlight with slides first. We have not. What about here? You have written this. Okay, there is no need. You are still going to write it, but if you want to write, fine, I can still wait. But what I'm saying is that the process we want to embark on, we start from here. So we are going to start by importing the library through which we are going to get the PCA what? Function, and then storing it in a data what? Series as what? PCA. Now here, once we have done that, you now import what? So this is still part of it, but I added center what? The data. So this is where you are centering the data. And what you did here is that you created a variable, just to explain it first before we go for the practical. We created a variable, and the variable name is, or an object name as data underscore centered, and then we subtract the mean. Remember, we explained this now. We have the mean of each value under the column from the actual what value. That is how we are getting the center. Now, here we try to view only two of the what? The centered what? Value by using head. So which means that these are the center value under what? TV show. The center value under what? Video game. Out of the three columns in the data set we are working with. And then just to explain further, I say what? You need to center each column around 0. I think we should write it because the practical aspect may not give us this breakdown like this. So 0 before applying a PCA model by either 1, subtracting the mean from each value, like I've explained before, standardizing the column. It's like we have written that. Written it, right? Okay, good. Now here we are using another function which is called the explain variance ratio. The explain variance ratio shows how much of the variation from the data is captured by each principal component. So since we have mastered the theory that we did last time, so each time I use principal component, I believe we understand what we are saying. So the first component will always capture the most variance, and then it decreases from there. Then the second part is the sum of the explained variance ratio across all components will be equal to what? 1. We are going to prove all this. So once you have executed this code, by the time you add all the variance together, if it's not equal to 1, then you know that something is wrong. So that equals to 1 is a standard, is a known standard. So what we are doing here is now we are viewing the explained variance by using the object. Remember that we have stored the number of what? The numbers of column into this object, the PCA small letter. Then we are concatenating this with the what? The ratio, and that outputted what? Array of 2 values, because we specify 2. So just to explain further, I said you can represent 88% of the information captured in the 3 original columns by only keeping 1 principal component. So by so doing, you have automatically reduced the number of what? Columns. Now, just to explain further, you can represent 97% of the information captured in the 3 original columns by keeping 2 words principal column. That is, this second explanation now talks about the option of us reducing from 3 to 2. While the first one is talking about the option of reducing from 3 to what? 1, like we indicated with those the lines and the illustration we gave the other time. So professional advice is that typically you want your component to capture 80% plus of the variance in your data. Let's go to our notebook to practicalize some of this theory that we have explained so far. So we're going to start by creating a new notebook, because we're working with one of the data we have worked with, but we are going to call it in a new notebook. So let me quickly go to, I've already created or set up my folder. So I'll just go to new and then Python 3. And then if it does not redirect, just double click. Then let me start by renaming it as according to the topic, which is let me say dimension. Reduction. So the next thing we are going to do is to read our data, the data we are working with, but we are going to start with preparation because, and I'm going to ask us a question, whether we can go ahead with this data. But let's read in the data first. So we start by importing our library pandas because we are used to this. So let me just quickly go ahead. I hope we all have this data now. We have it now. This entertainment underscore clean. We have it, and I know I must have given it to all before. If you don't have it, you will let me know so that I can send it across. So let me start by importing the necessary library. Library. So I'll say import pandas as PD. And then this is the only library I need for now. I may do away with NumPy if the data is not too large. So I'll say the name of the data df equals to pd dot read underscore. Let me find out if it is a CSV data. The name of the data is entertainment underscore clean. So I'll go into, if I've given us this data folder, you should be able to see it. So it's a CSV data, CSV, then call the part of the data to save my time. Right click and select copy part, come back to my notebook, paste, because so now on it, see what is it saying? No such directory exists. Okay. All right. Now to view my data, I'll simply type the name df, run it. So I have this data. So now I want to ask us that, can we actually pass this into model? What is the issue with this data? The name, right? Good. Because it is an identifier, right? So we have to drop it. So that will be, it's part of the data preparation we want to quickly look into. So the logic we are going to drop it is one of the logic that I have taught you before, right? The way of cutting, since it's isolated from the once unit, so you can easily use the ilog concept to cut it off without wasting time. And we are saving this particular copy in a different data set. All right, so the next thing is for us to, since we still have this copy, let me use comments. Now, let's prepare the data set by removing the identifier, which is the name column. So we are using the ilog. So I'm going to I'm storing the final copy in data object series, and then equals to df, that is, we are extracting it from df using the ilog. So I believe you understand the concept, because the ilog, when you are slicing, you are supposed to define the starting point to the end. But where you define only the starting point without defining the end point, it means that you are taking everything from that point to the end. That is the reason why we are not putting anything here. So if I run it, so let me see the outcome by entering the same name. Then you can see that with this, we have been able to cut off that identifier. So now we now have, because we were taught that any form of data set you are passing into analysis model should have numeric or true, right? All must be numbers. So the reason why we remove it, because these are not what? Number. The model can easily work with this. And we have 150 of them. Then we have just 3 columns now working with. Now, the next step is for us to calculate the mean. Remember the notes I gave you before. How is it going to get the center? You're going to also subtract the mean from what? The value. So we need to calculate the mean first. Let's even have an idea of what the mean. So that is the next step. Calculating before we center the data, let's check the mean. And that is simply the name of the data series you just saved, concatenate with the main function. So that will just output the mean of each of the values, the total value in each of the column. Now, like I said, let us find out the mean. So I'll simply say data.mean. So this is the mean. Now, from this mean that we have derived now, you remember the concept. We are looking at the center. We want to center. That is, this value, this mean value from each of these feature will be subtracted from the actual value there. That is how we get what? The center. So that will take us to the next. So the next step now, center the data by subtracting the mean from what? It's from the main data. So what we are doing here, like we have highlighted in the slide before, so we are creating a new object series called df underscore what? Center, just identify the center copy. Then we are taking the data set itself, and then we are subtracting the outcome of the mean, and that will give us the center points that will end up determining the number of what? Reduction, how many columns we can actually work with. So let's quickly go and apply this. So like I said, here we want to now calculate the center. Let's center beta. So say df underscore center, any name, is equals to data minus data dot the mean. If you run it, let's see the outcome by calling the objects. All right, so what we have here now is the center of each word column. So now I just want to display the first 4 or 5. So I will just take this and just add dot head. Just for us to be able to see it better. Okay. So the next thing now is for us to look at what then happened after you have centered what the data. So we are going to check the mean of the center value now, because the mean you checked before was the main value. Now I want to check the mean of the center data by simply calling that object. So let's check for the mean. The mean of the centered data by simply saying center D center dot mean. So I think I make mistake with my typing. Yeah. Okay, right. So, all right. Now, what do we observe? Observation. All the values are, is it what we actually have? They all correspond with my own. What do you have there? Now, let's look at it together here. You can see negative what? Minus 16, minus 16, minus 16. That is the observation I want us to note down. So observation, all the values are a negative what or minus 0, which means they are very close to what? 0. That is what it means. So now we can now model the data since we have found out all this key information. Now let's model it. So we have to now import. So what we are doing since is just making sure that the data is in the right format, which is preparation. Now we want to implement the PCA now. So we are going to start by importing our library, which is sklearn, and then from sklearn, we will now get the PCA as the function that will be reduced, that will be used to reduce the dimension of our data. So from sklearn, remember that it's case sensitive. Import PCA. The PCA, an object. Find the number of components, which represents the number of columns you want. Out of the 3 columns, how many of them do we want to capture? Then we now transform it by concatenating it with the fit function and then supply the centered data. Just a minute. All right, so let's quickly go there and implement. Okay. Have we all imported from sklearn? From sklearn dot decomposition. Import PCA, capital letter. So let me confirm this first. Hmm? The okay. Right. So let me create an object to store it as PCA equals to PCA and underscore components equals to 2, which means that we are reducing from 3 columns to what? 2 columns. That is the target. So let me also confirm this for so now let's transform it. PCA dot fit. Supply the center data df underscore All right. All right, so if we have applied that, let's look at the next thing. Now, we want to apply the explained variance ratio, which we are expected to have to sum all the values together, we should have what equals to 1, like I've highlighted in the first slide. So we just simply call the objects, then concatenate it with the attributes, explain underscore variance underscore ratio, the underscore. So what that will do is to give us the array. So let me quickly write also. Here, so PCA dot explain underscore variance underscore ratio underscore. Perfect. So what do we observe here after running this? You can see that data points captured by each principal component. So which means that out of the two columns, now I want us to observe something here. Remember that when we were transforming the data, or when we were storing we're defining the component, or let's say the number of columns we want, we supply what 2, which means that from the three columns in that data set, all the values must have been grouped into what 2 columns. Now, how do we know? Here now we have 2, which means that 1 represents one of the columns. Why this one represents what? Another column. So and even we are seeing like 3 of them, it means that what the 3 columns are still what represented. If we want to see it means that what the reduction has taken place from 3 to what to 2. Now let's proceed with here. This is where we are trying it for 3. If you want to try, you can just try that one for 3. Just go back to the first code, then edit from 2, or you can create another one. You can say PCA3. So just try that one on your own. I'll continue with it 2. Okay, now remember in the theory, we talk about what? Summing of what? The value. And then it should be equal to what? 0. So now let's sum them up. So you're going to sum the one you did for 3 and the one you did for 2 and see whether that will give you equals to 1. So since you did for, I think I will just go with, let me try and achieve 17 so I can be on the same page. So BC equals to 3. So all I need to do, I think if I don't want to rewrite it, okay, did you rewrite it? Yeah. Yeah, I think that from here. Yes, I just want to do for 3 so that we can be on the same page. Control C. And then I'll go change here to 3. Go to 3. Okay, I think that is. Then we do piece C3 dot to make it faster. No, I've not gotten to. Which song are you talking about? No, I've not. It's after this that I will get some. Okay, so now we just apply the sum of. Okay, so we just wrap sum. Just copy the whole of this inside the function. Control C. So we have 1. So this is an assignment, but it's going to be classwork. This is the last one you did now, eh? Which one? Two components. And what do you, how many do you have? Yeah, by terms of base, like 0.967. All of them should give you 1, as is the 3 of them. You know, at that point now, you remove 1 column now. It is when you add all of them together, you should get 1. Now, finally, that is how you can use explain variance ratio to choose number of what? Components. Now, this should be classwork. You are going to work with, there's a data set. Check your data, whether you have this data set that you require here. Read the student grade. From that data folder, there should be student grade. So if you can find it, so just quickly use it to do the classwork. Student grade. Is there, right? Yeah. Okay, so just use this to answer this question. I still want us to proceed. So let's take it as classwork so that we can continue. Confirm your results with mine. This is the data set you imported, right? Let me try to reduce this so much. This what you did. Let's be confirming, so I don't want to go through it. This is what you get. Here it with the values. This is where your the classwork should stop. Right? What did you get? So that we can start this topic. Or where did you stop? You went beyond where I stopped. Did you do something different from this? Just with the sum. Okay, the sum. Okay. That one is. All right, so let's quickly apply the interpretation of the PCA. Because we are actually going somewhere. We want to know at the end of the day. So here we are bringing in an attribute. Now, we are bringing in an attribute called dots components underscore attributes. So this will let us interpret the principal components. No, just write it when we get to where we want to apply it to look into it. Just for you to document first, that because in the application I may not okay, so here these are 6 steps we are going to go through, just like the way I highlighted the first section. So here you are visualizing it, trying to put it. Now, this is the preview of the principal components. That is when we reduce from 3 columns to 2 columns. Now, initially when we display them, these headers were not attached. So what we are doing here is that we are putting the data in a frame and we are passing in what header to represent what the 2 of them. Why? Because here you want to what represent it with graph. So you need to put them in 2 axes. So that is what we are doing. So you write this and then write this. And then I think after that, you should be able to start applying it.